Now, the fractionated column that is also referred to as the chamber has different trays where different fractions are going to be collected after heating. Now, the low boiling point fractions are collected at the top of the tray, and the low boiling fractions are called natural gas liquids. Now, after natural gas liquids are collected, or petroleum gases, you can also refer to them as petroleum gases, they are collected at the top of the fractionated column because they have the lowest boiling point. Now, after that, we have petrol, which is also called gasoline, is collected at a temperature of 342 to 363 Kelvin. And the fractions of petrol range from C5 to C8. That is petrol. The one that we call petrol in Nigeria is also called gasoline in the US and Canada. Now, when petrol is collected, we have kerosene, which is collected. The next fraction that is going to be collected is kerosene. This is collected. The fractions, the carbon fraction of kerosene is C6 to C11. After kerosene, we have gas oil. Yeah, I was trying to explain the heat value of various petroleum fractions, and I remember telling you that LPG petroleum gases have very high BTU, British thermal units. That is why if you are using a kerosene stove to cook and you are using a gas to cook, be sure that you are going to finish your cooking while using gas compared to while using kerosene stove. The reason is that LPG petroleum gas has more BTU, has more heat value than kerosene. Now that takes us to petrol. Petrol, also called gasoline, is also used as a source of energy. It's also a source of energy. Now imagine what the world would have been if there was no petrol, if there was no gasoline. Now we know that all automobiles, including bikes, all use petrol. What is driving the economy of the world presently is actually petroleum, and one of the basic components of petroleum, as I said, is petrol. That is gasoline. Now all vehicles run on petrol, except few that run on gas. That is diesel. Now that is petrol. Among other uses, one of the basic uses of petrol or gasoline is that it is used in automobiles, to run automobiles. Now we have kerosene. As we all know, kerosene is used also in cooking. is also a source of energy. It's used in cooking. But kerosene is also used in aviation. Also used in aviation in the form of what is called aviation fuel. Kerosene can be blended to what is called aviation fuel. That is also a fraction of petroleum or crude oil that is used to run jets, aeroplanes, helicopters, among other aviation industry. Now we have gas oil, which is also called diesel. Diesel is also used as a source of fuel. It's also a source of energy. It's used in running heavy-duty vehicles. Heavy-duty vehicles is also used to run industrial plants, among others, use of diesel. Now we have gas. We have other products that can be gotten from the fractionation of crude oil. We have asphalt that is used in tarry roads, used in roofing, among other uses. That is that. Now, I will talk about the fractionation of petroleum. I want to let you know that petroleum products, as we have them, are not just refined or fractionated and used directly as you have them. There are treatments that are given to them for the purpose of environmental conservation. Now, that will take us to what is called blending or octane number. We're going to talk about octane number. We're also going to talk about cetane number. Now, after you have fractionated or you have done your refining of crude oil or petroleum, it is not standard for you to pour it into your internal combustion engines directly like that. You cannot pour petrol after refining immediately into a car, into a generator, or into any other internal combustion engine. There are treatments that are given to them in the refinery. Now, those treatments are referred to as blending. Now, for most of us that are not covered with blending, we should know that most times some people go to the filling station to buy what is called oil treatment. Even after the petrol has been brought from the refinery, we are bought it from the filling station, from the marketers. Some people still go to another length of buying what is called oil treatment. They pour it inside the petrol and they shake it together and before pouring inside their internal combustion engine like car or generator. Those are all blending processes. Now, octane number by definition is a measure of the burning efficiency of fuels in internal combustion engines. Now, in this case, the fuel we are talking about is petrol. So, octane number is peculiar to only petrol. There is nothing like octane number for diesel. There is nothing like octane number for kerosene or petroleum gases. Now, as I said, octane number is a measure of the burning efficiency of petrol in internal combustion engines. Now, how does it burn in internal combustion engine? Is it burning efficiently or is it burning haphazardly? That will determine the octane number. Now, in chemistry, in organic chemistry, when we are treating alkanes, we know that we have methane, CH4. We have ethane, C2H6. We have propane. We have butane. We have heptane. Before we have octane. Now, octane is C8H18. That is where we get this octane number from. Now, the worst fuel you can have is normal octane. That is C6H12, straight chain hydrocarbon. When you pour straight chain hydrocarbons as a fuel, as petrol, inside your internal combustion engines, be sure that knocking is going to occur. What is referred to as knocking is going to occur when you pour petrol. That is petrol in form of octane. As I told you, H18. You pour it directly into your fuel, into your internal combustion engine. You are going to have a knock. What is referred to as knock. So what you do is to blend this octane, that is C8H18, you blend with other additives. They call it additives. you blend with additives. Now, when you blend with additives, what happens is that the straight chains are converted to branch chains. I believe you are getting it. When you put all those additives, you convert straight chains, which are the worst fuel, to branch chains or rings. So what you do is that you have converted straight chains to branch chains on one side and to rings on the other side. Branch chains and rings are the best fuel, especially rings. I believe the class is following. Now, when you convert to branches, it makes the burning efficiency of the fuel to be almost 100%, which means you are going to see less smoke. You are going to see less smoke, and you are going to see the generator working at, or the car working at a very fast pace to your own delight. Now, we have different types of fuel, petrol, depending on the type of blending that has been done. Now, we have what is called ordinary petrol. What we mean by ordinary petrol is that the blending is not so efficient. That is what it means to be ordinary petrol. Apart from ordinary petrol, we have what is called super petrol. We have super petrol, and we have what is called premium petrol. These things are they no longer use them in Nigeria as it used to be. But naturally, petrol is graded into ordinary, premium, and super, depending on the level of blending that has been done. That is what, and all these different grade of petrol, they come with different prices. Now, one of the major additive in the blending of petrol, mind you, the blending starts after the fractionation. You should follow the story very, very well, keenly. Additives are added. One of them is tetraethylene. That was the best additive that was used before now. Tetraethylene. That is C2H2. You close the bracket open C2H2 for PB. That is tetraethylene. Was one of the best additives to petrol after fractionation. But tetraethylene was discovered to be very dangerous to the environment. So for that reason, tetraethylene has been banned in many, many nations. In almost all the countries of the world has banned the use of tetraethylene. So now, the next we are going to talk about, I'm going to tell you how the blending is done. I'm going to give you a typical example. A fuel that performs as well as 1:1 mixture of 2,2,4-trimethylpentane. That is what we mean by 2,2,4-trimethylpentane is that when you convert a straight normal octane, when you branch it, you can branch it to many types of fractions. But the major one that is recognized in chemistry is 2,2,4-trimethylpentane. You branch up and down at number 2, and you branch up at number 4, giving you 3 branches. Merely branching that normal octane to 2,2,4-trimethylpentane has turned the normal octane to a better fuel. Is it clear to you? Now, I now said when you have a mixture of 2,2,4-trimethylpentane and normal heptane, I didn't say octane now, and normal heptane is a bad fuel. That is C7H16. Anything that is straight chain cannot be used as a fuel efficiently. So when you now branch and a normal heptane together, this is what happens. This is that you have branched, you have mixed 100%, a fuel that has 100% efficiency with a fuel that has 0%, that has no efficiency at all. You blend 100% plus 0%, 2 fuels in equal proportions. What you have is 50% octane number. At 50%, you know in an exam, if a student score 50%, that is a mediocre score. That is just average, just at the center. It cannot be rated as a good fuel. So what you have now, commercial gasoline, the one that is sold at the filling station, no matter when corners are not cut, industrially, is going to have an number of 81, 75, and 65 for the premium, regular, and ordinary. I come again. For normal blending of petrol and the different grades of petrol,
inorganic compounds found in living things. They are proteins, carbohydrates like sugar, lipids, which are fat, and wax nucleic acids such as DNA and RNA. Organic compounds can be very large and complex. A compound that does not contain carbon and is usually simple are called inorganic compounds. There are exceptions to this, such as carbon dioxide, and also this would include carbides, carbonates, and cyanides. But generally, inorganic compounds do not contain carbon. They also are more simple than organic compounds. So there we go. Organic compounds contain carbon. Inorganic compounds do not, except for the few exceptions. Thanks for watching, and Moving Math uploads a new math and science video.
Out of the activity of living things. But over the times, organic compounds can be synthesized in laboratory. For example, protein, inorganic compounds organic compounds are compounds which basically have atoms as the main element in their structure. Hydrogen, oxygen, nitrogen. While inorganic compounds basically do not have carbon atoms in their structure. Generally, they are oxidizers, strong acids like nitrogen chloride, strong bases like sodium hydroxide, and salts like natrium chloride.